Component Writing, Part 3. This article is the final part of a three-part article on components. This final part will cover property/component editors, how to write dedicated editors for your component/property, and how to write hidden components. This article originally appeared in Delphi Developer Copyright Pinnacle Publishing Incorporated. All rights reserved. Custom component editors. As soon as we start to write advanced property types for our components, life becomes a little more complicated. Although the Object Inspector built into Delphi is able to recognize most property types, it is impossible for it to be able to deal with every possible custom type we may write into our components. Sometimes the Object Inspector is able to deal with our custom types, but editing such a complex arrangement of properties in the Object Inspector is simply not intuitive enough. It is at this point we may be required to write property/component editors. Delphi has many predefined editors already. These editors are in the DsgnIntf.pas file in the $Delphi /source/ToolsAPI directory. You will need to list this unit in the uses clause of any component editor/property editor you may write. It is also a good idea to keep this file open for reference when writing your own editors. Coding standards. To start off with, I will cover some coding standards that are used when writing component or property editors. There are only a few, but it would be a good idea to keep to these standards when writing your own editors, as it makes it easier for other people to understand your work. When creating a property editor, and the name of your editor with the word property, for example Tangle property. When creating a component editor, and the name of your editor with the word editor, for example TPyChart editor. When writing editors, always write the editor in a separate unit to your actual component. It is good to separate the design time and runtime code, and, apart from this, it makes your resulting exe size smaller. On some versions of Delphi, your component may stop applications from compiling if you do not separate them. Also, separate the packages so that your users can build with runtime packages if they want to. Name your editor unit with the same name as your component unit, but append a word reg at the end. For example, a component with the unit name myComponent.pa would result in the editor file name being myComponentReg.pa. Finally, when writing a component editor/property editor for your component, move your register components statement out of your components unit, and into your component editors unit. This way your component will not be registered without the editor also being registered. The property editor. Property editors are used by the IDE to allow special editing of individual properties within a component. Some editors are very simple, some are much more complicated. Delphi already has a number of standard property editors. Some of these are T-integer property, used for inputting integers. T-char property, used for inputting a single character. T-enum property, used for selected an individual element in an enumerated type, al-top, al-client, etc. T-bool property, used for selecting true or false for Boolean properties. T-float property, used for inputting floating point numbers, variable type float / extended, etc. The real type should not be used for component properties. T-string property, used for inputting strings up to a maximum of 255 characters. T-set property, used for including / excluding individual elements of a set property. Each element is displayed as a Boolean subproperty. Setting the value to true includes the element, setting it to false excludes it. T-class property, this is the base class to descend from when you want to create a custom editor to be invoked for properties of a certain class. When you have a class as a property, such as timeage.picture. All of these property editors descend directly or indirectly from T-property editor. T-property editor has many properties and methods. The most significant are function al-equal, Boolean, virtual, function getAttributes, T-property attributes, virtual, procedure edit, virtual, function getValue, string, virtual, procedure getValues, PROC, tGetStrPROC, virtual, al-equal. When multiple components are selected, the object inspector filters its list of properties to only the ones that all the selected components have in common. If the value in each component for any given property, e.g. width, is the same, the value will be displayed. Otherwise no value will be shown. Al-equal is the routine that determines if each value is identical. Function T-string property al-equal, Boolean, var I, integer, v, string, begin result equals false. If prop count 1, then begin v equals get str value, for I equals 1 to prop count 1 do if get str value at I, v then exit, and result equals true, and in the above example T-string property compares each value, using get str value at with the value of the first component in the list, using getStrValue. GetStrValue at 0 would have done the same. The size of the list is determined by using prop count. This returns the total amount of components selected. GetAttributes is called by the IDE when it needs to gather information about the property editor. The object inspector displays an appropriate editor based on the information supplied. The result of getAttributes, T-property attributes, is a set, so it may contain a combination of the following values. This is not a complete list. PA dialog tells the object inspector to show a button after the property name. When the user clicks this button, the edit method is triggered. PA subproperties tells the object inspector to show a +expand button before the property name. Clicking this button will show an expanded list of subproperties, usually the published properties of a class property. PA value list. The object inspector will show a combo box with a list of values. This list is determined by the IDE by calling the getValues method. Note: the getValues method, not the getValue method, which is completely different PA-SART list. If combined with PA value list, the values displayed will be sorted alphabetically. PA multi-select. This specifies to the IDE that the property is allowed to be displayed when multiple components are selected. This item is not present for editors such as T-class property. PA auto update causes the setValue method to be called each time the value is altered within the object inspector, rather than waiting for the user to press or edit another property. This is used for caption and text properties, to give a live representation of the value the user is entering. Parrot only. If this element is included, the value in the object inspector is read-only. This is typically used in conjunction with PA dialog. GetValue would be overridden to return a descriptive representation of the property. Edit. This method is called when the button for the property is clicked. This button appears if the PA dialog element is included within the result of getAttributes. GetValue. This method is called when the object inspector needs to know how to display the property as a string. This is typically used when PA dialog, Parrot only are specified within the result of getAttributes. GetValues. This method is called when the object inspector needs to retrieve a list of values to display when PA value list is specified within the result of getAttributes. GetValues passes a parameter called proc, which is of type getStrProc. getStrProc is declared as getStrProc equals procedure, const s, string, of object. The IDE expects PROC to be called once for every value that should be displayed in the object inspector for this property. Procedure thint property.getValues PROC tGetStrPROC begin PROC first item to display PROC second item to display, and the following example shows how to provide a list of default values for the hint property of all components, whilst still allowing the user to enter a value not in the list. Type thint property equals class, tString property, public function getAttributes, tProperty attributes, override, procedure getValues, PROC, tGetStrPROC, override, and procedure register, implementation procedure register, begin register property editor, type info, string, nil, hint, thint property, and thint property function thint property.getAttributes, tProperty attributes, begin result equals inherited getAttributes plus PaValue list, PaSarity list, and procedure thint property.getValues, PROC. tGetStrPROC, begin PROC, this is a required entry, PROC, press F1 for more information, PROC, this value is read-only, and first getAttributes is overwritten, and PaValue list, PaSarity list are included in the result. Next getValues is overwritten and 3 values are added to the drop-down list by calling the PROC procedure. Registering property editors. Finally, the property editor is registered using Register Property Editor. Register Property Editor takes 4 parameters: property type. P-type info requires a pointer to a T-type info record. This sounds much more complicated than it really is. All we need to do is add typeinfo to our uses clause, and use the typeinfo function to retrieve the pointer for us. Typeinfo, some variable type, component class, T-class. This is the base class that this editor should apply to. The editor will apply to this class and any classes that descend from it. If nil is specified, this editor will apply to any class. Const property name, string. If this editor should only apply to a specific property, then the name of the property should be specified here. If the editor should apply to any property of the type specified in property type, this value should be editor class. T-property editor class. This is the class that has been created to deal with the property. In the above example, the class is thint property. Using register property editor incorrectly. It is important when using register property editor that you supply the correct information. Supplying the incorrect information could mean either that your editor affects incorrect properties, e.g. all string properties, or incorrect components. At the other extreme, setting the parameters incorrectly could mean that only a specific property in a specific component, and descendants, is associated with your editor. This does not seem like much of a problem at first, but descendant components may wish to implement additional properties of the same type. As these properties will obviously have a different name, they will not have the correct property editor assigned to them. An example of badly registered editor already exists within the VCL. The standard editor for T-collection was registered for all classes descended from T-component. The problem is that the lowest class capable of being displayed in the object inspector is T-persistent, the class that T-component descends from. If a component has a property of type T-persistent, which by default exposes its sub-properties in an expandable list, and one of its properties is of type T-collection, the result is a button in the object inspector that does nothing when clicked, as we saw in Part 2 of this article series. The solution to this problem seems quite simple. Rather than our sub-property being descended from T-persistent, we could descend it from T-component instead. However, the default behavior for a property of type T-component, as determined by the property editor T-component property editor, is to show a list of other components, rather than the sub-properties of an embedded component. The actual solution really is simple, but only if you know how to write a property editor. Step 1. Type T expanding record equals class T persistent should be changed to read type T expanding record equals class T component. Step 2. Create a property editor like so. Type T expanding record property equals class T class property. Public function get attributes, T property attributes, override, and procedure register, implementation procedure register, begin register components, article, T expanding component, register property editor, type info, T expanding record, nil. T expanding record property, and T expanding record property function. T expanding record property dot get attributes, T property attributes, begin result equals parod only, PA subproperties, and Step 3. Remove the register components call from the component unit, and register it within the editor unit instead. This way we can ensure the component will not be registered without the component. Now our property of type T expanding record will show as an expanding property, due to us returning PAS subproperties from getAttributes, and the default editor for tCollection will work as the owner of the tCollection property is a tComponent. Dialog property editors most of the time, when creating a custom property editor, the purpose is to provide a graphical means of interacting with the property. This first example is a very simple way of allowing the user to enter multiple lines in the caption property of a T-label. Although this example is not very complicated, it demonstrates how to include a form within your editor. Step 1. Select File, New Application from the main menu. This will create a form. Name the form FM Label Edit. Add a T memo to the form named MEM Caption. Add 2 buttons, OK and Cancel, with the modal result properties set to MROK and MRCancel respectively. Step 2. Add DsgnIntf and TIP-info to your uses clause. Step 3. Add the following property editor code to your unit. tCaption property equals class, tString property, public function getAttributes, tProperty attributes, override, procedure edit, override, and register the property editor like so. Procedure register, implementation $r*.dfm procedure register, begin register property editor, type info, tCaption, tLabel, caption, tCaption property, and Step 4. Add the following code in order for the object inspector to display the Edit button after the property name. Function tCaption property.getAttributes, tProperty attributes, begin result equals inherited getAttributes plus PA dialog, and Step 5. Finally, we create an instance of our editor form, set the contents of the memo to the current caption, and then show the form modally. Procedure tCaption property.edit, var I, integer, begin with tfm label edit.create, application, do try mem caption.lines.text equals get str value, show modal. If the modal result of the form is MROK, we need to set the caption property of each T-label. If modal result equals MROK, then for I equals 0 to prop count 1 do T-label, get component, I, dot caption equals mem caption dot lines dot text, finally free, and, Step 6, install the unit into the package, and then try out the new editor. Advanced property editors. Anyone who has ever used tActionList or tDataset, tTable/tQuery, will have experience of the following example, possibly without even realizing. The action list editor is obviously a custom editor as it allows grouping of actions, whereas the fields editor of tDataset may at first seem like a standard editor, but upon closer inspection has a pop-up menu with items such as Add Fields. However, the most remarkable feature of both of these editors is not that they are custom dialog editors, similar to the one we covered earlier, but the fact that the items they create are included in the main class declaration of the current unit. Type tform1 equals class, tform, actionList1, tActionList, action1, taction, action2, taction, private declarations, public declarations, and the benefit of this is that the IDE is made aware of these items, therefore allowing them to be selected from a list of objects whenever the property of a component requires them. In the above illustration, two actions are added to a tAction list. Clicking the action property of button 1 shows a list consisting of the actions added. The two actions are also added to the form's class declaration, and can therefore be referred to by name, action 1, action 2. The trick here lies entirely in the property editor and not within the component. When a property editor is triggered, i.e. the edit method is called, the designer property contains a valid reference to an iForm designer, tForm designer in Delphi 4. Many of the functions of this interface are not within the scope of this article. If you wish to learn more about the capabilities of this interface, I would recommend a book called Delphi Developer's Handbook by Marco Cantu. Some of the methods include function method exists, const name, string boolean, procedure rename method, const cur name, new name, string, procedure select component, instance, tPersistent, procedure show method, const name, string, function get component, const name, string tComponent, function create component, component class, tComponent class, parent, tComponent, left, top, width, height, integer tComponent. Some of the above calls are fairly elementary. Method exists, for example, will return true or false depending on whether or not a method name already exists within the form of the current unit, form create, button 1 click, etc. Show method will move the cursor to the named method, and rename method will change the name of a method. The two methods that are of interest to use at this point are create component given a component class, a parent to hold the component, and position/dimensions, the designer will create an instance of the class as if the developer had selected it from the component palette and added it to the form themselves. Modified informs the designer that something has been altered, a property, etc. This alters the state of the unit so that the IDE knows it should be saved before closing. It also enables the Save button in the IDE. When adding items to our array, all we need to do is to get tMyProperty.designer to create a component on our behalf. This component will then be added to the form, and any property that refers to a class of this type will automatically be aware of it. In the case of tActionList and tDataSet, the components that are added to the form are not visible at design time. The owner component acts as a kind of manager for the components. During design time, you won't see a tAction or a tField component on the component palette, which would possibly make you suspect they are not registered, yet the IDE is still able to create instances of these components, and they are also not visible. The answer is not that they aren't registered. This behavior is a result of how the component is registered. Whereas register components will add your components to the component palette, the register no icon method will register your component without adding it to the component palette. Registering in this way also tells the IDE that the component should not be displayed during design time. In the following example, we will create a component called a T-Wave sound. An additional component called T-Wave button is included in the source code that accompanies this article as an example. T-Wave sound will simply hold data from a WAV file, and play the sound on demand. Although it would be simple for us to drop one T-Wave sound onto our form for each wave sound we require, our form could soon start to become unmanageable. Therefore, we will also create a manager class called TWaveList. Every technique used in the source code to these components was covered in Part 2 of the series of articles, so the source code will not be covered in any great level of detail. However, I will show the class declarations of these components just to give you an idea of how they are structured. Note, at the bottom of the unit, within the initialization section of the unit, you may notice the following code: initialization register class, T-Wave sound. The reason is that register no icon doesn't seem to do a complete job. Although it allows us to create instances of the registered component from our property editor, something seems to go wrong when a project is reloaded containing these components. A class not registered message box is displayed and the project is corrupted. Additionally, registering the class in this way seems to fix the problem. T-Wave sound type pwave data equals $T-Wave data. T-Wave data equals packed record size, long int, data, array 00 of byte, and T-wave sound equals class, T-component, private F-wave data, P-wave data, F-wave, T-wave, procedure read wave data, stream, T-stream, procedure write wave data, stream, T-stream, protected procedure defined properties, filer, T-filer, override, public destructor destroy, override, procedure clear, procedure load from file, const file name, T-file name, procedure load from stream, stream, T-stream, procedure play, published end. F-wave data will be used to store the contents of the wave file once loaded from a stream or a file. Clear will free the memory holding F-wave data. Play will use the DsgnIntf.pas sound API call in mmsystem.pas.